But for today, it will be solving questions on geometric sequence and series. Let's look at the question we have here. Okay, please, as you are coming in, just begin to say I. Okay, welcome to this channel. Welcome. As you are coming in, just begin to type I. Our populations of an ant is growing at a rate of 10% a year. 200 ants in the initial population. Okay, write down the numbers after 1 year, 2 years, 3 years, and 10 years. Okay, so this is the question we have. The initial population is what? Is 200 what? 200 ants. And then we have the growing rate is 10%. So the first thing we need there is what? The multiplication factor. There is an increase. That'll be 110 over what? Over 100. Okay, and that's 1.1. That's the multiplication factor. Is increase. So that'll be 10 plus 100. If it's decrease, it's the dot 100. Okay, so question A, the number after 1 year to the initial population times what? The multiplication factor 1.1. Okay, you can multiply that. That's for A part. So point your calculator. As you're coming in, just begin to say I. As you're coming in, just begin to say I. Welcome. Yeah. Check your calculator. Then the B part, number after 2 years. The numbers after 2 years will be the initial population times what? The multiplication factor. That's a 1.1 to the power 2. Then the C part, the number will be what? After 3 years, that will be what? That will be 200 times 1.1 to the power 3. Then you get you point your calculator and get those this value. Okay, so that's that on that. Then we'll go to the 10 years, the numbers after 10 years. That will be equal to the initial population times the multiplication factor to power 10. And that's what we have there. Okay, that's what we have there. As you're coming in, just begin to say I. Okay, just begin to say I. And if you have your own question, you can type it on the comment section. I will respond to that. Okay, so that's that on this question. Let's get this value on the calculator. The first one, that's 220, 242, 6. And last one, so that's what we have for that question. This is a question we have. Motorcycle has 4 gears. The maximum speed in bottom gear is 40 km/h, and the maximum speed in the top gear is 120 km/h. Given that the maximum speed in each successive gear form a geometric progression. Okay, calculate in km/h to 1 decimal place the maximum speed in the 2 intermediate gears. Okay, so this is what we have there. So let's see the interpretation to this. Okay, as you're coming in, you are welcome to this channel. Okay, just begin to say I as you're coming in. And if you are fresh to this channel, if you are new on the channel, please subscribe so as to keep track of the update of this channel. Thank you for doing that. The geometric progression is going to be the first one will be A. The second one will be what? Will be AR. The third one will be uh, AR2, okay, and the fourth one cube. So these are the what? These are the uh the maximum speed, okay. In the bottom gear, that's your first written one, that's the A. The maximum speed in the top gear, that will be this one, AR cube. So, and then we are told to find the intermediate what? The intermediate gears. Okay, that is the second 10 and the third 10. That's what we are looking for. So this is the progression that we are able to form. The maximum speed in the intermediate gears. So the maximum speed in the bottom gear is your A. Your A is what? Your A is 40. We are going to start with the given information. The given information, this one and this one. The maximum speed in the top gear, which is the what? The fourth 10. That will be what? AR cube equal to what? 120. Substitute your A there, which is 40 times what? Times R cube equal to 120. Make your R cube the subject. So we have 3. So R is equal to what? Cube root of what? So that's the common ratio. This one should be 1.442. Okay. So that's that. Then we've gotten the common ratio. We can get the second term, the U2. Okay. Which will be equal to what? This one. That's maximum speed in the second gear. We're going to find the third one. Okay. And that will be what? That will be U3. And that will be equal to what? AR squared. My A is 40 times 1.442 squared. That's a 3.2 for that one, kilometer per hour. This one also kilometer per hour. Okay, so that's that on that question. Okay, that's that on that question. That is the maximum speed in the two intermediate gears. Two intermediate gears. We've gotten this maximum speed in the second gear, and then we've gotten the maximum speed in the third gear, which is 83.2. This question, the fish in the population area of the North Sea have been reduced by 6% each year due to overfishing. How long will it be before the fish stock are half? Okay, the fish in a population area of the North Sea are being reduced by 6%. So that means the multiplication factor, but under minus 6, that's 94%, and that's 0.94. Okay. How long will it be before the fish stock are half? So that means after n years, okay, and then we said the numbers of fish, let it be what? Let it be b. So that will be b times the multiplication factor 0.94, okay, to power what? To power n after numbers of years, and is now half. So that will be 1 over 2 times b. How long will it be before the fish stock are half? Okay, so this is the numbers of fish which we don't know. That's the initial numbers of fish. This is the multiplication factor. Okay, then is half. So multiply both sides by 2. So we have 2b equal to what? 0.94 n equal to what? B. So this one cancel. Make this one the subject. Okay, you got what? 1 over 2. And take the natural logarithm of both sides. So that will be natural logarithm of 0.94. This one will come to the front. This will be this. Okay, so that's what we have. Then we can make the n the subjects. So n is equal to this one over ln 0.94. That'll give us 11.2. So that starts on this section. If you're new on the channel, please subscribe to the channel so as to keep track of the updates of this channel. The next episode will be some of geometrical sequence and series. Some of geometric sequence and series. Okay, see you the next episode. Bye bye.